Welcome to Financial Analytics. In this video, we are going to learn about matrix in R. Basically, matrix overcome the limitation of a vector in R. Vector is a one-dimension data structure where vector has only length and no height attached to it. So in matrix, every data element has a row as well as a column index. So matrix is a two-dimensional data structure, and in finance we frequently see matrix data structure. Just imagine where you are searching financial data on our websites like Money Control or economictimes.com. Then in those cases, our financial data has a columns, financial years, and in row there is a financial variables, income, expenses, profit, EPS. So that data represent the matrix. So there are a few websites which present their data in the form of matrix. So let us understand how to create a matrix in R, and then we apply financial data of a financial statement in matrix. So let's move ahead to whiteboard. So now let us understand how we create a matrix in R. To create a matrix, we write a matrix and then open and close the parenthesis, and that will create a matrix. So that is a basic function of a matrix. And what is the syntax and what are the arguments that matrix use? The first argument is a data. The data for the data, we need to understand that the matrix accept only a same data type. So in R, there are numerical data type, logical data type, character data type, then integer data type, complex data type. So when we create a matrix, you have to remember that the data that R in matrix accept is of a same data type. So we can either create a logical matrix, or we create a character data type, we create a number data type, or integer data type. So the data type will remain the same while creating a matrix. Then what is this n row? The second argument is n row. N row defines how many rows will be in the matrix. Now third argument is n column. Similar to n row, n column, we define how many columns do we need. Now the last argument that R matrix use is a dim names. Now dim names means a dimension names. The dimension names means what rows and column names will be. So this is a one format of a matrix, and you can see here this is a two rows. This has a two rows and 5 columns. So this is a basically 2 by 5 matrix. So this has a 10 data elements, and here I am defining n row is equal to 2, and by default the n col will be 5 because 5 columns and 2 rows will fix the 10 data elements matrix. So this is the matrix, the way we create, and the syntax used in the matrix in R. So let's move ahead to our studio. So let us focus on how to create a matrix in R. To create a matrix in R, just write a matrix and then write a data. Here I am giving a data of a sequence of 9 numbers which commence from first and end at 9, and storing a data in a variable A. And once I hit variable A, I get a matrix which has a 1 column and 9 rows. You can see here, as I am not defining how many rows I need or how many columns I want, by default R is returning me a 1 column and 9 rows. So let us define rows and columns. So write down A and then matrix and data, and then how many rows we need? We need 3 rows because there are 9 data points. So the default matrix that we can create 3 rows and 3 columns which can fix the 9 data elements. So our matrix is ready, and now you can see here the matrix which is a 3 by 3. 3 by 3 means 3 rows, 3 columns, which fix the 9 data elements. And what is the most crucial points that you have to remember, that when you are not declaring how to arrange the data, R will arrange the data column wise. See here, the first data, the second data, and third data is arranged in a first column. Then next data is arranged in the second column, 4, 5, 6, and last data is arranged in the last column, 7, 8, 9. So we can also define or declare the way we want our data to be. So change the order of the data and just write down here how you need a data. By row is equal to true, and then R will arrange the data row wise. Now you can see here the data is arranged in rows 1, 2, 3, and next 4, 5, 6, and then 7, 8, 9. So in this way we have changed the order of the data. So now let's move ahead. Now understand how to access the data elements from the matrix, or how to access the group of elements or group of data, how to access from the matrix. We can access the data points column wise as well as row wise. So first create a vector of 8 elements and store it into the H, and we will create a matrix. So matrix of H, arrange the data row wise and give me 4 rows. So my matrix is ready. There are 4 rows and 2 columns. So to access this data elements, let us understand the theory behind accessing the data elements from the matrix. So let's move to whiteboard. So let us take one hypothetical example of R matrix output. So this is the R matrix output, and if we want to access the data elements, then the format is open and close the square bracket and use the comma. Now this comma will separate the rows and the columns. So in this way, before, if the number is before the comma, then that represent the row. If the number is after the comma, that represent the column. So for example, take one example. If I want to access something like this, so the number is before the comma and the number is 1. So this number 1 represent that I want to access the first row, and R will return me the entire fixed row. And if I write something like this, comma and the number 1, now after the comma, whatever is the number represent the column. So this indicate the comma and then 1 indicate give me a first column. Here the number 1 is before the comma, so what is indicate give me a first row. Now if I want to extract only this point number 4, now what this point number 4 indicate? This point number 4 indicate that it represent the first column and first row. So how I write it? First I will open and close the square bracket, then I will write a comma. The number before the comma is a row, so this is a first row, and the number after the comma is a first row. So first column, first row is 4. Now if I want to extract the 26 number, how I will access it? Open and close the square brackets and then write give me a 4th row and give me a second column. So that will return me 26. Accordingly, we have to access the data points. So if I want to extract this entire 4th row, I will simply write give me a 4th row and then I will give comma, and then I will get the entire row number 4, and the data points will be 20 and 26. So accordingly, we can access the data elements. So let's move to RStudio. So now let us understand how to use financial data in a matrix format, and then we will understand by how to add operating profit and how to get a dividend when we have Infosys sales data and Infosys expenses data only. So what we know is a sales minus expenses is a profit. So we only have a sales and expenses data. So with the help of this data, we will create a profit, and then we will add that to the matrix. Out of with the help of the profit, we will get a dividend, and then we will add that dividend to that matrix. So let's move ahead. We are using this function info matrix, and then we are using here the C. C is basically a vector of Infosys sales and Infosys expenses. So we are combining two vectors, that is the Infosys sales and Infosys expenses. And if we check how our matrix looks like, so our matrix is look like this, where we have a column names financial years, and in the rows we have a revenues and expenses. So in this way our matrix will look like when we use this function. So try to understand what is this function. So we have first created an Infosys sales vector. Then we have created Infosys expenses. That data we can get easily from the websites. So we created this vector, and then we create this matrix functions to which we add these vectors Infosys sales and Infosys expenses. Then we ask R to give me data row wise and give me 2 rows only out of this data, because in my first row I need a sales data, and in my second row I need only expenses data. So that's why I have defined n row is equal to 2. And then I ask R to give me my data in a row format. So my data is arranged in a row wise, where rows are only 2s. The first row represent the Infosys sales and second row represent Infosys expenses. Now when I have used these dim names functions, what these dim names is basically dimension names functions, to which I have given the revenue and expenses labels. These the first labels are revenues and expenses. So these by default goes to row, and then I have given these financial years that by default goes to columns. Now if I want to find out only the profit of Infosys, what I will do, I will simply create a new vector which will store Infosys profit, and I simply write give me Infosys first row. What is the first row of info? First row of info is this entire revenue data. So this is our first row, and minus info, and give me a second row. And the second row is what? Second row is basically this expenses data. So this expenses data is basically info 2. And now if I hit give me info profit, I will receive this Infosys profit. Now what we will do, we will use a rbind function which will bind this Infosys profit data to our Infosys matrix. So what we will do, we will create a new matrix, new info, and to this new info we will bind our Infosys profit data with the function rbind, and then write info, which is our original matrix, and add this our profit data, info profit. And now if you check what is in the new info, now our data is a revenue, expenses, and then Infosys profit is also bind. So we have used our bind function for the adding that Infosys profit to the our original Infosys data. So now our entire data is now into the new info data. Now for the sake of example, hypothetical example, we will assume that the dividend rate of Infosys is 10%, that is a 0.10. And if we want to compute the dividend of Infosys, and we will find out that dividend Infosys of dividend, and then again we add it to the original new info matrix. So let us see how we can do it. So dividend is equal to, we will store our data into a dividend, and what we will do, we will find out the Infosys profit. Now the Infosys profit is into new info and in the third row of a new info, and we will multiply with dr. What this dr? We have declared dr as a 0.10. So dividend, we can check dividend. Now we can see here, this is a dividend 2782, 2445, 2003.4 and 186.4. so these are the dividends of Infosys. We are taking this as a hypothetical example. Now if you are confused in this code how that we get a dividend, we can remove this dr because we have declared this dr as 0.10. so we can simply write 0.10 and you will get the same answer. So here you can be getting the same answer. Now this is my final data, so I am writing here final Infosys and I am adding this dividend data to our original new info. So new info, and I am binding this dividend data to it, and see how our final info looks like this. So we have this original data, revenue and then expenses, then we created this info profit, and then we multiplied this info profit by 0.10. Here we get a dividend and we attach to it. So this is where our final Infosys data or matrix looks like. Now what we will do, we will move ahead. What kind of statistical applications we can do? So to do a statistical analysis, we need to access the data elements from this matrix. So let's move ahead. Now if I want to see the revenue of a final info, so try to understand this form. My entire data is now into a final info, so I am doing a statistical analysis on this final info. Now I want to see a revenue over the period. So what I will do, I will write final info, then square brackets, then 1 and then comma. Why 1? Because 1 give 1 and then comma will return me entire first row, and in my first row there is a revenue. So I want to see a revenue, so I am giving a 1 comma. So now you can see here, this is my revenue. Now I will bar plot on it. So I will bar plot final info, then 1 comma, and here I will get a bar plot for the revenue. I can change the colors, give me a color of rainbow, and there are 4 colors, so that's why I am using a rainbow 4. So in this way you can get or access the first row of revenue. Now if I want to see only a dividend, the dividend declared by the Infosys, so this is a hypothetically dividend actually. So final info, bar plot of final info, and give me 4th row, because in my 4th row of final info there is a dividend data. So 4 and then comma will return me a dividend, and again I will use a color of rainbow, and there are 4 columns, and here you can see this is a dividend data. So I can write main is equal to dividend, and now you can see on this bar plot the dividend. So in this way we can compute this part apart from this, we can also find out the mean revenue. So if you want to find out the mean, just write a mean here. So mean of final info, my sales data is in a first column, so I am writing 1 and then comma. So the average revenue you can see in the R console, that is 85,510. Similarly, I can find out the mean profit. So mean, then final info, and then I will write 3 comma. What is this 3 means? My info profit is in the is a third row, so that's why I'm writing here 3 comma. So the average profit of Infosys in last 4 years is 22,748. Similarly, I will like to find out the variability in this profit. So I have to calculate standard deviation. So standard deviation of final info and 3 and then comma. So what this 3 and comma does? 3 comma means give me the third row, and in my third row there is a profit data. So this is basically standard deviation. Standard deviation is a 4,190. Now we need a peer company's data to understand the importance of the standard deviation, as we don't have a standard deviation data. So we cannot compare, we cannot claim on it whether this is a good or bad. So apart from this, we can also find out the summary of final info 3 comma. 3 comma means give me entire profit data row wise. And now you can see here, this is the profit data. This is basically our profit data. So minimum profit is 18,000. The first quantile means 19,695. The median data is 22,000. So the mean is 22,000. Third quantile is 25,300, and maximum profit is 27,828. So what this median indicates? So if we arrange our data into increasing order, so the most middle value of a profit is 22,000. What this third quartile indicates? The most of the profit, data, or 75% of the data is below this 25,300. So in this way, we can find out the statistics, or mean, median, standard deviation, variance, or we can also find out the range. So these are the statistical analysis that we can apply on the matrix. So in this way, we have done statistical analysis with the matrix of Infosys. So thank you, and now we are concluded at the end of the matrix. In next session, we will move on to data frame. Thank you.